What's up, class? I want to start to look at section 5.2. I'm going to give you some notes here that cover the whole section, and then we'll take a couple days in class to work on the homework and get all that situated, so don't worry about that quite yet. Just let me tell you what's happening here. So this is section 5.2, the definite integral. The definite integral. And fear not, this is just the area under the curve. This is what we've been talking about, and also in pre-calc a little bit, talking about area under the curve. First, I would just want to note something. We're going to add this to our memory quiz. Y equals r squared minus x squared, the square root of that. We've dealt with equations like this a few times. This is a circle. Whoops. This is a circle with radius r at the origin. Centered at the origin. Centered at the origin. And over the years, this has come up a few times, and I just kind of assumed that you knew that. I want to throw it out there. This is something you need to know. If you see an equation like this, so if 16 is there, minus x squared, 16, that means the radius is 4. And you would draw that up. And that comes up every now and then. That's just something you need to know, and I'm adding that to our memory quiz. Okay, let me give you a statement here. Back to the definite integral. With words, we say things like this. With words, we say the area under f of x. The area under f of x between A and B, between a couple of different numbers. The area under f of x between A and B. And we've said that, maybe we've been more specific. The area under x squared between 1 and 7 or whatever. And we've used rectangles to approximate that, or geometric methods if it was a straight line. But that is something that we've said. Let me do something else. Let me draw a picture of this same thing. A picture might look like this. We have a graph, and there's my line, and there's A, and there's B. Okay. Well, that is this area right here. This area. Okay, so that these words in that picture mean the same thing. Let's try to fix that focus a little bit. Did not help. There we go. That looks a little bit better. Okay, so that's the area under f of x between A and B. Let's say that this is f of x. Okay, I'm going to say the same exact thing. I'm going to say it in a couple different ways, though. The first way is kind of weird, and we won't actually use it that much, but I need to throw it out there. The summation notation. Okay, and that will look like this. The limit as n approaches infinity of the sum. This capital letter sigma means sum. Okay, now this is going to be a bit much for a second. Just stay with me. From k equals 1 to n of f of c sub k times delta x. Okay, and you're probably screaming at me, what does this mean? This is all foreign and odd. Well, okay. Basically, this is kind of talking about our rectangles. This is the height of the rectangle, right? The function value. This is the height of the rectangle. Okay? And this is the width of the rectangle, the change in x. And we usually pick those rectangles so they have the width of 1. But this is the width. Okay? So the height and width of the rectangle. This bit right here means we're going to add up the rectangles. And this little bit right here means that we're having an infinite number of rectangles. And if we have an infinite number of rectangles, for any values that we plug in there, if we have an infinite number of rectangles, that'll give us the actual area. So that is what this is saying. Okay? And if that is totally beyond you, there's only going to be a few problems on that, and hopefully you can translate it just from using that information. You're basically just going to take this function here whatever it is. But we'll deal with that when we get to it. So that is the summation notation. And finally, the one that we are going to use all the time, the integral notation. Integral notation, and we used this a little bit in pre-calc last year. It's that big S. Okay, I'm going to put A down here and B up there. Okay, the function is f of x. I'm going to put dx. Okay, so let's see here. F of x, that comes from here, and d of x, that's our infinitely small width there. So that's what this means. This is the area between A and B underneath the curve. This is the notation that we will use all the time in calculus. Okay, that's integral notation.